Good morning everyone, welcome to our channel Engineering Phantom. So today we are going to make a video on write operation of 60 SRAM cell. We will go for a write operation and we try to write 1. So basically you can see we will perform write 1 operation on 60 SRAM cell using Cadence Virtuoso tool, and we are using 45 nanometer GPDK library. Before starting the video, I will request all of you please subscribe our channel and like and share our videos if you like it. So if you subscribe our channel, then you will get notification for the upcoming videos. I have planned to do all the analysis on 60 SRAM. Let's start today's session. As you can see, we have already designed a 60 SRAM cell. If you don't know how to design it, then there is another video uploaded in this playlist for designing the schematic cell. You can see on our channel playlist. Okay, so let's start our write 1 operation. So let's start it. So here is our schematic, and here I have already defined values in ADL Studio. I have shown in first video how to design, how to put this value. So we applying analog stimuli, and here I am showing all the input pins I have given for write 1 operation. So first of all, the word line, it will be first low and then turn on after 5 nanoseconds. Okay, so here is showing. So let's make some changes in word line. Okay, and before that we can see all the pins are given here: VDD, QA, QA bar, DLB and DL. So here I am giving the pulse width. Okay, I am adding the rise time and fall time in picoseconds. If we don't add, then so next is our vision as a DC voltage. Give it DC value 1 and apply. Move to the next bitline bar. So it will be, and you can see here, voltage 1, first voltage 1 is put in high because we want to reach. We are doing the write operation, so it's bitline bar, and we are doing write 1, so we have to give voltage 1 and second voltage 0, because if we are writing 1 on the QA node, so QA bar node will be written as a 0. So we are giving voltage 2 as a 0, because when word line gets high, we start write operation. So word line getting high in voltage 2 after 5 nanoseconds. So here also we have decided we want to write 0 here on QB bar, so we give voltage to 0 and voltage 1. Time period is here is 10 nanosecond and delay is 5 nanoseconds. So after 5 nanoseconds the pulse will get high, and we have given rise time and fall time 10 picosecond each. The pulse will be 5 nanoseconds. Okay, so let's move forward. So all bitline bar inputs are given, apply. Next is bitline. So here, as you can see, we are trying to write 1. So bitline bar will be charged. When the word line get high, it should be QA node. And here time period of the pulse will be same, 10 nanometer. We have given pulse as a function of input. Delay time will be 5 nanoseconds. So it's showing after 5 nanoseconds pulse width will be high, and okay, so pulse width will be 5 nanoseconds. So let's write rise time and fall time here also. So 10 picosecond apply. So press apply, and then so next is our ground signal. So it's also DC function. DC voltage value is 0. Apply. Told you in QA in schematic design that how we taking all these values. Okay, from this option of ADL, select input and outputs. We already shown this in schematic design video. If you find it any difficulty, you can go and watch that video. So let's move forward. So here I have chosen the analysis transient analysis for 10 nanosecond, as all the pulse periods are 10 nanoseconds. So here also I have given 10 nanoseconds because we are doing for 1 clock period only. So let's move forward here. Okay, here I am again showing how to select the signals. We need bitline,